Geometry Lesson 4.2. We will be talking about angle relationships in triangles. Um, as we've already learned about, I don't know if we've officially talked about, but the triangle sum theorem states that the interior angles of a triangle add up to 180. So A plus B plus C would be 180 degrees. Okay? So if you look, when you draw this line, you can kind of see where this came from. That if you draw an auxiliary line to help you out, 4 plus 2 plus 5 would be 180, and then the top and the bottom lines would be parallel, and you could see that 5 and 3 are alternate interior, and 4 and 1 are alternate interior from before. So that's kind of how the triangle sum theorem came about. All right. Find measure x, y, z. All right, so x, y, z would be here. 62 and 40 is 102. Leave 78 for y. Y, w, z. Y, w, z. Whoops, get my pen there. So that's this angle over here. Well, this is 12. X over here would have to be supplementary to 62, so that's what, 118? So then 12 plus 118 is 130, which leaves 50 degrees for our W. Use the diagram to find the measure of MJK. MJK. So figure out where we're looking at here. That would be this angle right here. We can see that these two angles are the same, the red ones. So 88 and 48 would be what here? 88 plus 48 is 136. Subtract that from 180. So that would make this angle 44, which means this angle also has to be 44. So 104 plus 44 is 148. And then that leaves 180 minus 148, 32 degrees for your answer. So use the things that we've learned about angles and go from there. All right. Two corollaries. A corollary is a theorem whose proof follows directly from another theorem. So a couple corollaries that we know. Acute angles of a right triangle are complementary. So if F's a right angle, then D and E have to also add up to 90. And each measure of an equiangular triangle is 60. Take 180 divided by 3, you get 60. So the measure of one acute angle in a right triangle is 63.7. What's the measure of the other? You would just take 90 minus 63.7. And that equals what here? 90 minus 63.7, 26.3 degrees. The measures of one of the acute angles in a right triangle is x. What's the measure of the other? Well, to find, subtract it from 90. And since you do not know anything else about it, it's just 90 minus x. All right. The interior is the set of all points inside a figure, and the exterior is the set of all points outside the figure. So 1, 2, and 3 would be interior angles. 4 would be exterior. Okay? Interior angle is formed by two sides of a triangle. An exterior angle would be like 4, formed by one side and the extension of an adjacent side. Okay? So exterior and interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. So if you're looking at 4, 1 and 2 would be remote interiors to 4, the exterior. All right? So the exterior angle theorem states the exterior is equal to the sum of the remote interior angles. So 4 is equal to 1 and 2. So if you wanted to find that, you would take the exterior, 5x minus 60, is equal to the sum of the remote interior. So 5x minus 60 equals 2x plus 18. Subtract 2x, add 60. So x equals 78 divided by 3 is 26. but it asked us to find angle B, so I got to take 26 times 2 plus 3, 55 degrees. Okay, let's try that again. 6z minus 9 is the exterior, equals the sum of A and B. 2z plus 1 plus 90 would be 2z plus 91 if you had the 90 and the 1. So I'm going to subtract 2z. I'm going to add 9, divide by 4. So Z turns out to be 25. It asked for ACD, which would be that angle right there. 6 times 25 is 150. Minus 9 is 141 degrees. The exterior angle theorem. All right. The third angle theorem, also known as the Kmart theorem, buy two, get one free. If you know that you have two angles of one triangle are congruent to two angles of another, then the third angles are congruent. So if you know L and M are the same, or excuse me, L and R are the same and M and S are the same, then you know that N and T are the same by the third angle theorem. Okay, so if we're going to apply this, we can see here that these two triangles, G and H, are the same. F and I are the same, so we can assume that K and J are the same. So we can set them equal. Okay, so I'm going to subtract 4y squared from both sides, which gives me 2y squared. I'm going to add 40 like that. Divide by 2. So y squared equals 20. Now, make sure your last step here when you have a squared is you take the square root. So we can say y is the square root of 20. Now, when I plug that back in, I take 4 times the square root of 20 squared, which would be 20. And that turns out to be 80 degrees. And that also would be 80 degrees. Make sure when you're setting them up this way that you take your square root last. Okay, let's try that again. N and S are the same. M and T are the same. So we can set 2x squared equals 4x squared minus 32 because of the third angle theorem. I'm going to subtract 2x squared. I'm going to take 32 and add 32 to both sides. Then I'm going to divide by 2. So now x squared equals 16. Last step is to take the square root of both sides. So x equals 4. Then I'd want to plug that back in. 4 squared is 16 times 2 is 32. So if that's 32, this is also 32 degrees. Okay.